Yo, welcome back. All right, we're going to learn some two big time rules here in taking the derivatives of specifically products and quotients. So we'll start with the product rule. So the product rule is when you want to take the derivative of two functions. So the product of two functions. So in other words, how would I take the derivative of f of x times g of x? Well, according to this is what you do. It's going to basically be f of x times the derivative of g of x plus g of x times the derivative of f of x. So now remember, we talked about this, right? The derivative of a product is not the product of the derivatives, right? We don't see this equaling the derivative of f times the derivative of g. It's actually equal to this sum. The way I like to remember it is I would identify f of x as my first, right? My first factor in the product, g of x as my second factor in the product. And the way I remember it is, all right, so then the product rule says the derivative is going to equal first times the derivative of the second plus the second times the derivative of the first. That's how I do it. All right. Sometimes certain textbooks, you pick them up, they use u's and v's, where u is like f of x and v is like g of x. So the derivative of uv is going to be uv prime plus vu prime. It's saying the same exact thing. It really is up to you on how you want to remember it. So now, right, we wouldn't feel good about ourselves if we didn't tell you where this crazy rule comes from. Well, it should be no surprise that it comes from the definition of the derivative. So if the function I'm trying to take the derivative of here is f of x times g of x, right? Maybe the first or the biggest step in all this is, do you understand that this line right here is just the definition of the derivative, right? So this is just us applying, right? Limit as h goes to 0, function evaluated at x plus h, but my function's a product, so that's why I see that, minus the function. Remember, my function's a product all over h. And then all of this good stuff, you can pause the video here and you can write it out and you can see what's going on. All of this good stuff now is just kind of algebraic manipulations of fractions and sums. The one thing that's a little wackadoo is what you see in blue and red. We actually had to add that to the numerator in order for us to kind of simplify and see what we needed to see. Now, I'm allowed to do that because if you think about it, I'm really adding 0 because this is minus this stuff and this is plus the same stuff, right? So I'm really just adding 0. So I'm allowed to do it, but the reason why I do it is because it allows me to manipulate and end up getting that product rule that we set up top, right? Which is right here. First times the second plus second times the first. So again, if you want to pause it and pick through that, knock yourself out. If you have questions on it, you can ask me an extra help. So let's go now to example 1. It says find the derivative when y is equal to 3x squared times x cubed plus 1 using the product rule. All right. So how do I do this? So I have y equals 3x squared times x cubed plus 1 using the product rule. So that's a product of two functions, right? This is a function and this is a function. So in order to take the derivative of a product in calculus, I'm going to want to use the product rule. So product rule says, in our own words, first, that's the first function, times the derivative of the second. Well, the derivative of the second, the derivative of this, is going to be 3x squared plus 0, right? Because the second is a sum. So the sum is a sum of derivatives. So that's just going to be 3x squared, all right? Then plus the second, so I'm going to want to wrap that up, right? The second times the derivative of the first, right? And the derivative of the first, or the 3x squared, that's just going to be 6x to the 1. So that represents my slope producing machine for the graph of y. So, all right, let me spruce this up a little bit. dy dx, we got 3 times 3, that's 9x to the 4th. Here, when I distribute, I'm going to get 6x to the 4th plus 6x. I notice I have like terms here. So my slope producing machine ends up being 15x to the 4th plus 6x. And I got it using the product rule. Now, what's this all about? Well, let's check our answer by multiplying y out first. So in other words, I could have given you this problem today before teaching you the product rule. And you would have said, all right, he never taught me how to take the derivative of products, but that's okay, because what I can do here is I can simplify y first, which is always a huge skill when taking derivatives. Sometimes it would behoove us to rewrite y, right? So I can do that because I can distribute the 3x squared here. So if I do that, I'm going to get 3x to the 5th, right, plus 3x squared. So all I did was simplify y. Notice I wrote y equals here, right? This is still y. And so what is it? Well, it's a sum now. And in each part of that sum, I have a constant times a function and a constant times a function. And we have derivative rule for that. The derivative of a constant times a function is just a constant times the derivative of the function. So when I go to do this, dy dx, right, it's going to be 3 times the derivative of x to the fifth. That's 5x to the fourth. So I'm going to get 15x to the fourth. And then here, 3 times the derivative of x squared, 3 times 2x to the 1, plus 6x to the 1. And you're like, wowza, look at that. That's the same exact thing. So why am I showing you this? One, so when you see that product of your rule, you're thinking there's no way that actually works. Well, here's evidence that it actually does work, right? The next thing, though, you might be thinking is, well, all right, listen, why teach me that crazy rule? You know, why don't I'm just going to do it this way. I'm just going to multiply it out every time, right? You think about why it would be incorrect logic to think that way, and we'll get back to it as we keep going here. All right. Example 2, find the derivative of each of the following. So here we go. So hopefully you just thought about it, right? What do I have here? This is x times sine x, right? X is a function. Sine x is a function. That's a product of two functions. There's nothing to distribute there. I can't make this a sum like the problem I just did. I don't have a choice. I have to use the product rule. So, all right, f prime of x. Here we go. First, that's x, times the derivative of the second. What's the derivative of sine x? It's cosine x. You have that memorized. Plus the second, sine x, times the derivative of the first. What's the derivative of x? Well, that would just be 1. So that's it. So if I want to spruce it up and just write this without the parentheses, I have x cosine x plus sine x. That represents the slope-producing machine for the graph of f, and I did not have a choice. I had to use the product rule. Guys, make a note. This is very different than if the problem was f of x equals, say, 5 sine x. That's a whole new ball game, right? Because that's not a function times a function. That's a constant times a function. So the derivative of that is just constant times the derivative of the function. Now, you might be like, well, it's still a product, right? So why couldn't I do the product rule? So why couldn't I say, all right, 5 is my first, so first times the derivative of the second, cosine x, plus the second, sine x, times the derivative of the first. Well, what's the derivative of 5? The derivative of the constant is 0. And you're like, oh, look at that. So believe it or not, the product rule actually does work in this situation, but this is wasted energy, right? And time is very important in this classroom, right? We have to be efficient in how we solve solutions. So we don't want to ever do the product rule when it's constant times the function. All right, let's take a look at this guy. What do I got going on? A lot of times you're going to ask me, hear me say, hey guys, what do we have? So you look at g of x, what do we have? And you're going to say, we have a product. So then I would say, how do you take the derivative of a product? And you would say, the product rule, right? It's amazing how calculus just makes so much sense. So this is my first, this is my second. I always want to identify my first and my second when I'm doing the product rule. So here I go, g prime of x. It's going to be first times the derivative of the second. Now, what is the derivative of e to the x, right? It's easiest one in America. It's just e to the x, okay? Plus the second, that's e to the x, times the derivative of the first, and the derivative of x is just 1. I put the derivatives in red there, right, for your enjoyment pleasure. All right, so here we go. So g prime of x, simplified, spruce it, x e to the x, just plus e to the x. And there's your slope-producing machine. And we had to use the product rule, okay? Let's keep going. Let's go to C. So here we go. So we got a whole bunch of stuff going on now, right? Not only do we have a difference, because that's a minus sign, where this is the first part of my difference and this is the second. Within the first part of the difference, we have a product. So 2x is my first factor in that product, and cosine x is my second factor in that product. So when I go to take the derivative, I have to use the product rule on that. So first times the derivative of the second. What is the derivative of cosine x? It's negative sine x. Remember, if you take the derivative of a trig function beginning with a c, it will be negative. Then I have plus the second cosine x times the derivative of the first. The derivative of 2x is just 2, right? And then close that out. That just represents the derivative of the first part of the difference, that part. Remember, the derivative of a difference is the difference of derivatives. So that's why I can get after this like that. Now I'm going to go minus the derivative of the second part of the difference, right? So what's the story with that? Should I do the product rule on that? Well, hopefully you know the answer is no, because this is a constant times a function. So the derivative of that is the constant simply times the derivative of the function. And the derivative of sine x is just going to be cosine x, all right? And so now if I spruce what I have here, it looks like I'm going to have negative 2x sine x, right? Plus, this would be 2 cosine x. Don't you dare try and multiply this x and this 2. This is cosine of x and times 2. These don't play together, right? Hopefully you know that. And then here I have minus 2 cosine x, and this is just a nice little coinky dink that these guys are going to sum to 0. All right, so h prime of x now is going to be negative 2x sine x when I spruce it up. All right, underline these in a nice little mustardy yellow. All right, they're going to sum to 0. Cool. All right, let's take a look at this guy. Y equals x squared ln of x. So what's the story there? A little bit more straightforward. All right, we have a product. All right, so now take a look at this. You ready? Let's pretend for a second I don't know, my name is Mo. All right, and I'm going to go, and this is Mo's work here. Mo's work. And I'm going to be like, all right, I like the dy dx notation. I'm going to go ahead and I'm going to say, all right, derivative of x squared 2x, derivative of x 1 over x, x is cancel. Oh, cool, I get 2. All right, and I put down, Mo puts that down on a test. All right, pause the video. Tell me why that is not right. All right, hopefully you're saying because the derivative of a product is not the product of derivatives. This is no bueno, right? If you have a product, you have to use the product rule when taking the derivative. So product rule says, first, my first factor is x squared times the derivative of the second, all right? Plus the second times the derivative of the first. Derivative of x squared is going to be 2x to the 1. So now dy dx can spruce a little bit here, right? What's the story with that? You're going to have an x factor go into that, so that just ends up being x, right? And then here, again, resist this urge to multiply this x and this 2x. No way, guys. This is ln of x. That's the input for that ln function. It ain't getting multiplied with that 2x. Right? Hopefully you're chuckling right now. So it's going to be 2x ln of x. And that's what you end up getting, all right, using the product rule. Cross that out, make it look nice and pretty. All right, again, don't lose sight of what you're getting. This is the derivative. What is that? This is the slope producing machine for the graph of y, otherwise known as the instantaneous rate of change producing machine for the graph of y. All right, so that's big time stuff right there. All right, let's rock and roll. Let's kind of get a little fancy with some of the questions. So here we go. Let f be a differentiable function such that, so I give you two things here. I tell you that f of 3 equals 4. So first off, what does it mean that f of 3 equals 4? That means when you input 3 into the function f, you get an output of 4. Well, that to me is a point. That's 3 comma 4. All right. Now, what does f prime of 3 equaling 5 tell us? Well, you now know that f prime means the derivative, and f prime of 3 means the derivative specifically at 3. So that would be the slope of the tangent line on f at x equals 3. That's going to equal 5. So just good information to know. So when you see things like this, you're going to have to know how to translate it. All right, so now maybe not necessarily in this particular problem, but in another problem. So now in this problem, it says, all right, if g of x is equal to x squared f of x, what's the value of g prime of 3? So they're asking you guys to find g prime of 3, but here's the deal. If they want to find g prime of 3, I want you on your paper, in your work, to first find g prime of x. They want g prime of 3? Great. I'm going to find g prime of x first. So I have to take the derivative of this. So you're like, well, okay, what's the deal? This is a product of two functions. In order to take the derivative of a product, you guessed it, I got to use the product rule. So here we go. First, that's x squared, times the derivative of the second. The derivative of f can be written as f prime of x. So that's first times the derivative of the second, plus the second times the derivative of the first. Derivative of x squared is 2x to the 1. There is my slope-producing machine for g. So now what do? Well, now they want g prime of 3. So my next line would be g prime of 3. Notice this says g prime of x. Notice all the x's. Now I do g prime of 3. Just chuck 3 in where you see an x, right? So that's 3 squared times f prime of 3 plus f of 3, and then times 2 times 3. And you just kind of knock this out now. 3 squared is 9. F prime of 3, they told me that was 5. All right. F of 3, they told me that was 4. And 2 times 3 is 6. So I end up getting, let's see here, 45 plus 24. So what is that? It's going to be 69. So G prime of 3 ends up equaling 69 here. Okay, so I didn't need to translate any of the information this way, but I want you to start getting in the habit of doing that, because like if I ask you to write the equation of a tangent line, for example, and I give you stuff like this, it's going to be real easy to do when you realize what it is they're giving you. All right, pretty cool stuff. All right, so that's it. The next video is going to be on the quotient rule. This was on the product rule. Take care. Cool.